So good morning, everybody. Thank you very much for joining this event at Hardware Pioneer Max 2022. My name is Amir Sherman. This is the Israeli type of English that you will need to bear this 40 minutes on. Okay. I've been working for Arrow Electronics for almost 20 years as an engineer, embedded engineer, marketing manager, and I relocated to Germany, to Frankfurt in 2013. Did a 7 years role there as embedded director for Arrow. So doing so many projects that I can count, supporting the embedded market. And COVID made me aware that I'm already 20 years in the company, so this is the time for change. So I decided to leave the company, and I joined a very, very cool company called Edge Impulse. But in the end, I'm doing the same thing I did in Arrow. I'm driving semiconductor business development, adding more semis to the platform, so then the engineering community will be able to win more of what Edge Impulse can give. So Edge Impulse is the leading embedded ML platform, and today my job is to give you a couple of examples of what and how Edge Impulse are doing, how they're adding semiconductors into the platform, and how you can nurture, get support out of it to simplify the way you are adding machine learning to your embedded application. So, there's so many information about Edge AI, and this is something that I love, saying that by 2025, more than 95% of new industrial IoT will deploy Edge AI. And is it in 95% or 70%? We all understand that today technology is the next revolution of IoT. We can add machine learning to microcontrollers, something that 10 years ago, 15 years ago, we didn't even thought about it. You need to do machine learning algorithm, you use a DSP. But today, technology, you have so many DSPs inside semiconductors, and then you can utilize it in the right way. And the problem is that it's complex. It's extremely complex. So if I'm an engineer and I want to run machine learning, I need to jump between platforms. There is no any one platform today that you can take a data, upload data, forward data, train the data, and then goes all over the end until you literally see it programmed as C, C++, Python to your end application or a Linux machine. There is none. There are some softwares that are doing some of it, but not all of it. And this is the one thing that when I want to explain the engineers community what Edge Impulse is doing, is that exactly it. You can take any data, and you know that it will go up to the end. You will be able to deploy it, and then test it, test your model, and then start training again. Because if you want a perfect model, you need the perfect data. And how much is the perfect data? It's infinite. If I have 10 years of data, my models will be the best. So in the end, what you will see as a customer for Edge Impulse is only everything on the left side, on the right side, so not in the box. The box is our box. It's a web-based platform. And what you need to do is that, you have your end device, and you put it in the box, and something happens in the box. But from your perspective, in the end, you are getting a C, C++ file or a Linux application that can run. There is a magic inside the box. And the magic is split between the tuner and the compiler, that these are, our main IP that we are driving. So what you need to do is that you just go to edgeimpulse.com, and later on you can see them outside really when you go out. Get the barcode, log in 2 minutes. It's totally free, and you will see the business model later on. And the first thing you will see this, how to collect data. And it's all about you. You can have automated way to collect data. You can have a voice data, any type of sensing data, or vision type of data. And then when you take the data, you label it, and it's your job. And this is where the magic started. So a lot of algorithms you have, neither MATLAB ones, neither professional algorithms or any type of models, the YOLOs and the ResNets, and you can bring your own models and you put them here. And this is where it's getting a little bit complex in a matter of neither you use the graphic user interface and click the button because you are embedded engineer, you don't have any clue, or you're an expert in Python and you can go to the expert mode and start putting your code inside. we support both ways. And then there is the tuner that is able to run some machine learning automated platform to tell you how much inference time, how power consumption, how much DSP usage, flash RAM. And this is where it's getting interesting, because I will start to check. You can see in the green the DSP time, the neural network time, and size of the memories. So it gives you a lot of ways to understand how you want to drive your models, but the most important thing, what to choose. And in the end, when you're going to deploy, there is a list. You need to scroll down, and there is all amount of boards and silicon that we are supporting. And this is the story of today's presentation, because I'm not here to talk about Edge Impulse. You need to try it, and there is a very simple way how to try it. It's more about how we simplify our way to your machine learning application. To do that, we need to support a lot of semis. And this was my job when I entered to Edge Impulse. I'm added more and more semiconductor companies, and you can see that there is a lot of comprehensive hardware support today. Many of the semis are being supported. And they're doing investment. They are working hard to have really full debugged support into our platform. So we tested their chip, their solution, and then you are benefiting out of it. You can, using their boards, already have your board ready, and our job is that it will be very easy to deploy the machine learning. Now, this is the problem. What to choose? Normally, I can have a Cortex-M4 utilizing the DSP inside. It's enough for machine learning. Or I can use multiple microcontroller with dual Cortex-M4, M33, or M7, and they have more DSPs. And you know what? Maybe I saw this company called Synaptics, and you see them here, and they have their neural network engine cores with some of special DSP from Tensilica. And they are utilizing machine learning, and they're doing it in a unique way. Or companies like Sentient. And there is something called neuromorphic engine. That I didn't understand what is Cortex, and you are jumping to neuromorphic engine. And then ARM just announced the new Cortex-M55 with acceleration called Ethos-U55. What does it mean? And if this is not enough, what is going on the high end? So, TI have these multi-DSPs, and you have GPUs, and you have special IPs, and NVIDIA that is doing a great job on the GPUs. What should I choose to my application? Because there are so many parameters I need to take into my consideration. Power consumption, size, development, ready box, doing my own hardware design. All of that is something that I need to take care of my new design. So what you need to do is that you need to split it in this direction. So now we have ultra-low power application, normally for wearable, a handheld application, voice command, anomaly type of detection, going up to high-end where it's more on the high-end vision. So for example, Sentient and Renesas are being supported on the low end, and these are coming with special neural network engines or microcontrollers with multi-cores. And we just announced Infineon with the PSOC-6, and we have Silicon Lab with a special acceleration. And when you go up, you need a little bit more unique power, but not horsepower, machine learning type of power. And when you go all the way up, you need to go up to the microprocessor. So for example, Renesas is the first microprocessor that we are supporting running dual core Cortex-A55, and you will see that in my presentation. And really, really finishing, TI announced the TDA4VA that it's for really big DSPs applications, fighting against NVIDIA, for example. Now, we are not stopping on that. We are having support on IPs. So all of these companies are IP companies that these new silicon guys are checking, and they are consulting with us, which type of IP should I use for my application? And this is also important because we are talking to a lot of IP companies. Now, I see a lot of faces like, he's talking too fast, and I don't understand him. This will come, okay? So what I'm going to do today, I'm going to share an example of one of each, and what we did for them, how you can utilize it, you as a user. So let's start. Silicon Labs. Silicon Labs is a wireless semiconductor company. Everybody know them, okay? Supporting the Zigbees and the Bluetooths and the Thread and now Matter, and this is perfect. And we talk to them, and we utilizing this already a platform that we are working for in the last 3 years, and they are announcing general purpose Cortex microcontroller, and they want to drive machine learning into the edge. So this is from their presentation. They really believe that having machine learning on the edge with ultra low power, and then after I'm finishing to drive that algorithm on the edge, I can send some result out via wireless. This is what the customers want, and they're exactly right. So ML for any wireless application, ML as a feature, and this is how they see that, and they're totally correct. Now, their technology is ARM-based, Cortex-Mx. So they're using Cortex-M4, they're using M33, meaning that they're utilizing the DSP functionality for machine learning, because in the end, machine learning is data, data is mathematics. And they just announced a new chip. Now, this chip, the EFR32MG24, maybe you saw it, maybe you didn't. It's a general purpose Cortex-M4 machine learning wireless chip with MVP. Okay, the MVP, it's a multi-vector platform, like a small coprocessor that is enabled to run more mathematics inside that, meaning that the micro can do some of the machine learning and the coprocessor can do other stuff as well. And this is where it starts to be tricky, how to utilize it correctly. And neither you're using their platform, and then there is need to be translation for that coprocessor, or Silicon Labs cooperate with Edge Impulse. And then we really were able to drive machine learning application with that chip. And think about it. 10 years ago, 5 years ago, to run an object detection on a Cortex-M with a coprocessor was like science fiction. And that specific chip, the small one, we connected to a small Arducam 2 megapixel, and we were able to run real object detection on a microcontroller. Now, for some application, it's perfect. Think about home security application, any type of wearable. You can run machine learning on that tiny machine and then go back to sleep, saving a lot of power. Use that, check it, and then you remember my box. Customers can take that board, play it, integrate, deploy, see if it fits, if it's relevant for you. And you don't need to be a machine learning expert for that. And there are so many examples we did. So this is a screenshot from our platform. Normally, you see on the left side, you have the devices that you choose, data acquisition that we are here, the impulse, and then tuning up to the deployment. So you can choose all of that type of sensors: microphone, accelerometer, environmental, Hall sensor, initial, ambient, and you can read. And this presentation, I believe, will be shared later on. And this is very important because you have the data, you can run it on a general purpose, low-cost, low-end microcontroller. And this is what Silicon Labs want, and this is what you engineers want if you want to test a simple type of application. Now again, Nordic came to us, and we started to work with Nordic Semiconductor. They are here as well. And they are also being playing in the same market that Silicon Labs is. So for example, they announced this NRF5340 SoC. Now, great device, building a dual-core Cortex-M33. And again, everybody's writing suitable for machine learning on the edge. Excellent. Yes, you have the DSP inside the core. It's suitable for machine learning on the edge. You remember 5 years ago, 10 years ago, IoT, everybody supports IoT. Now everybody supports machine learning on the edge. And this is OK, because this is what the market needs. Now you see that device, there are coprocessor, you have the application processor, you have the network processor, you have everything what you need to develop your wireless type of application. This is perfect. And they announced this Thingy 53. It's like a small box. I believe they're showing it. What they wanted, they want something unique. So they wanted that you will be able to have your machine learning training up to the deployment really on the edge node, meaning that you don't even need your computer. You can use an app. So what we did, Edge Impulse firmware already flashed when you get it. What does it mean? That when you turn it on, pop, you have an app. And then the same thing you wanted to do on your PC, on your working station, doing the training up to the deployment, now you can do it on the app. So you select the device, you connect to a new device, and then after it connected to your network, you successfully connected to the machine, and then you can start data. You remember data collection? Here it is here. And then you can start collecting data in real time on the field, for example. And we have a great partner here working with us doing machine learning based on Nordic for wind turbine application. And this was the reason that they chose that. And you can record new data. And after doing that, you can start sample the data. And you can, when this is finished, you have the functionality to build, update, compile on the edge, and when it's done, you deploy it. And you see the inference in a sec. This is what we did for Nordic. So again, we did it for Nordic for you guys, for the embedded engineers that neither you are an expert on machine learning, so you can run your models, bring your own models, go into the bits and bytes on the Python, or you just C, C++, Python embedded engineers, but still you got a task to run machine learning, you can do it in a very easy way. Now, we saw two examples of general purpose Cortex-M based on ARM. One that is general purpose, Cortex-M55, we saw the Nordic one, and we see Silicon Lab with that coprocessor. And we'll see this more, we see roadmap, 5 years roadmap for most of the semis, a lot of interesting things will come. Now, there are some other companies that are talking to ARM, and they are evaluating what ARM is doing. So Alif Semiconductor is one of these companies. Now, before talking to Alif, let's talk about what ARM is thinking. So ARM, as you can see, focusing a lot on the edge AI, and they moved to the endpoint AI. To do that, they announced new cores. So it was the Cortex-M55, the new one after M33. Maybe you saw it, maybe you didn't. And normally it came with a machine learning acceleration called NPU, Neural Processing Unit, that is the Ethos-U55. Now, a combination between both of them will give you, up to X, 15 on ML uplift on the machine learning, only utilizing the M55, plus a 32 on the combination between both of them. Why? Because the micro NPU have an integrated MAC that is built in the core, meaning that all the machine learning mathematical applications run on that coprocessor. And this is where you see the difference. Maybe you saw that, maybe you didn't. New technology from ARM. So you can see speed to inference and energy efficient versus a typical Cortex-M7, or a general purpose M55 alone versus M55 with U55 together. Now, Alif is the first semiconductor company have samples using that technology. And in the end, what they did, they take the latest M55 core that was focusing from ARM to drive AI application, connected to a U55. This is the first micro NPU. And by the way, they already announced the U65 that are normally connected to microprocessors. And then you have a dedicated configuration that are able to do this uplift. So Alif, startup company from California, the founders came from the semiconductor industry. There is already 350 employees. And the first silicon was last year. So they are really now in production, and we are supporting them. And there are many companies that already evaluate that technologies. And what Alif is doing, they announced this Ensemble family. So Ensemble E, E1, 3, 5, and 7, meaning that you are jumping from a microcontroller and an AI machine. So you have one core of M55, 160 megahertz, and one core M55, 400 megahertz with two Ethos, up to a quad core that you are even adding a microprocessor. You see it on the bottom, the Cortex-A32. So what we as Edge Impulse did for them is that we work with them, and you can see that a microcontroller can run full object detection by far more than what a general purpose one in less than 1 millisecond. And this is the E3 device. So the E3 having, and this is the most popular one, one M55, 160 megahertz core, M55, 400 megahertz core, and 2 Ethos acceleration. And this is the most unique one. And you can see at 400 megahertz, 0.786 milliseconds versus a microprocessor Raspberry Pi Broadcom that is doing it in 17 milliseconds. And you can see it here. So I will encourage you to run any type of object detection using Edge Impulse And we have something called FOMO, the faster object, more object. It's our own model to run this type of application. In a microcontroller, consume 18 microamps per megahertz. Incredible. ARM and a leaf. I will pause here. Question. Please, a microphone will come.
Hi, thank you very much. One of the key things that always hits me when we talk about the massive improvements in speed, and particularly when you look at edge deployment AI, is at what cost does this come? Because it's great, you can have a CPU or whatever it was at $120, but then once you integrate that into your full build, it becomes incredibly expensive, especially as you're building devices to scale. So where does the balance point and the trade-off between AI at the edge versus cost come in?
Great question. So, you are bringing back to the aero time when I need to sell chips. But in the end, great question. The reason that I'm showing the microcontroller in the beginning, the Nordic Silicon Labs and a leaf, these are all $3, $2, $5 devices. And Edge Impulse is free for the general users, unless you are becoming a professional user. You will see it later on, and then it's a SaaS subscription. But in the end, you are absolutely right, because most of our customers saying to us, I got a job for my boss to run object detection, face detection, anomaly detection, and they're automatically thinking about NVIDIA. And that NVIDIA, it's a $50, $100, $200, and you need to do it in a $20 BOM. There is clearly this, and NVIDIA did a wonderful job, brainwash everybody that AI is only them, but this is where the market is changing. And we see bombs now, bill of materials, going to production in less than $20, $30, depending on the application. We are here to support you exactly for that. And I'm just in the middle of my presentation showing more examples that are even cheaper, depending on the application. Okay? Great question. So, just to continue on that question, I understand that they can run my application on microcontrollers, but for my specific Edge AI application, my job now to run a Linux machine. Okay? So I need to choose a Linux machine. I can go to Raspberry Pi. I know it's very famous here in UK, but in the end, it was not meant to be production ready. And you cannot buy the chips, or it's not, meant for the industrial use, or maybe it is, but I want to work with the professional and industrial semiconductor companies. The only choices you have here is NXP and Renesas. And Renesas was the company that worked with us. So they announced, really last year, this chip called RZ-V2L. It's a microprocessor with a dual-core Cortex-A55, latest ARM technology, running at 1.2 gigahertz, having a dedicated AI accelerator called DRP-AI, their own IP that can really vectorize, multilize machine learning on the edge. This is their IP. And you have all of the connectivity that you need. It's supporting a Linux machine, so you have DDR4, you have the dual gigabit Ethernet, the USBs, massive amount of UART connectivity, and you have all of what you need for video and graphic decoding that you can see with camera. So this is a typical high-end Edge AI application that you will connect one camera, 4 camera, to run it for a high-end access control, face recognition, one-to-few type of application. By the way, this is a project that we are working. And this is a good example. Now, Renesas said that their DRP-AI is complex to understand. There is a specific translator, and you need to understand which model you want to use, and they want to utilize their models, and you need to jump between platforms. This is why they connect to Edge Impulse. So we really, very fast integrate their platform, and you can see here an example that we are showing. This runs very fast, our FOMO platform, and we are working now on the latest YOLO V5, working with them, fully integrated, and you can deploy it very, very easily. So you can continue to work in a normal way, buying a system on module based on Renesas partners, utilizing that devices, and we are working with all of the storm vendors on that, or design your own hardware, And then you need to know that from the machine learning perspective, edge import already simplify your way, and we are really easy integrated to the platform. So then whatever type of model you want to bring or bring your own model is being fully optimized under this processor. And this is very important. And again, a typical Linux BOM of this is like a $50-ish Linux BOM. So there are several European companies and American companies. I just came from California. I'm still jet lagging. And we saw a lot of application, some based on different form factor, the SMARC, OSM, big, small, even the European companies with SODIM utilizing that solution. And you can check that. So after we went from a microcontrollers, general purpose Cortex, and we went to a Cortex with coprocessor, and we saw a new ARM technology with an M55 U55, we went up to a Linux machine, and we saw that we are supporting Linux. Now we are even supporting specific IPs. And you saw several examples of them. I chose for this discussion BrainChip. Now, I believe that most of you never heard about this company. It's an IP company that they are selling their IP to the semis, but they also have their own chip. And they are doing a neuromorphic solution. Now, neural network engine need to mimic the neural brain, just to make it as simple as possible. A neuromorphic engine need to mimic a neural brain and the neural nervous system from a neuron mathematics solution. And you will see a lot. We are working with 5 new neuromorphic IPs and semiconductor companies. So what is a neuromorphic computing AI? Neuromorphic computing is a method of computer engineering in which elements of computer are modeled after system in the human brain and a nervous system. And this is important, very complex. And again, these devices need to be used on embedded application. So BrainChip announced the Akida neuromorphic IP. It's a specific IP, and by the way, Renesas already licensed that, and many others already did. And funny, it's already been implemented on an automotive application in one of the Mercedes. And you will see an example. So what they're doing is that when you have a lot of models, so from previous application, normally it's a one model. Here, when you need to run multiple models, so I want to do in the same time face recognition and voice recognition, immediately, spontaneously, on the fly, on the edge, no Ethernet or internet connectivity. This is like science fiction, but this is what developers are doing now. So you can do vision, audit, gesture, all of it in the IP, and there is specific CNN and SNN. These are neural network type of acronyms for machine learning applications. And what they are doing, they compare themselves in the high-end one. Okay, so now we are comparing not on the low-end micros and processor, we are comparing to GPUs. So again, a customer said, I need to put NVIDIA into my automotive application or to my home gateway AI application. I cannot do that. This is where things are getting nice, because you're comparing to a GPU. And you can see that what you can do in a 300 megahertz IP of Akida, normally a 900 megahertz GPU will do from a performance or from a clock speed application. And this is important, because we need to check to compare ourselves from a CPU, GPU, microcontroller, neural network, neuromorphic, any type of acceleration. The market is growing more and more and more and more. So we connected with BrainChip, and BrainChip was working with us to have this type of application. And the idea is that we simplify how to utilize this neuromorphic solution to the platform. And there is a very simple demo here, showing in a video that can explain more than I can talk.
And when I talked about Mercedes earlier, here's an example of what the future of the cabin in the vehicle is going to look like. We've got 3 networks that are running simultaneously. One is going to recognize you by face, one is going to recognize you by voice, and one's going to recognize you as individuals are in the vehicle. And the future of that's also going to recognize the gender and recognize the age.
Hey, Akida.
Aaron, all systems active.
You see on the right side, you see in the middle, and you see on the left side.
Talk. All systems active.
So what makes this fun is the fact that, again,
So, again, so BrainChip is not suitable for every application. It's complex machine. A leaf is not suitable for every application. Normally, you should use a general purpose microcontroller with a coprocessor for one application, versus you can use a GPU or a neuromorphic for a different one. Yeah, they want to sell their semis all over the place. It really depends on you, and this is where we are helping you guys to be able to simplify the way that you can test it before you are choosing. Now, these are semis. With that semis, we already engage with customers because in the end, we need to make a living. And this is a good example of customers that went public with us, so nothing here is confidential. We can see industrial application with collaboration with a German company called Baluf and Ready Robotics for machine learning on manufacturing, adding machine learning to the robots, so then you know exactly the positioning. And for a wearable application, there are a company called No Watch that literally doing no watch. It's showing how much you are stressed. And again, you need to train a lot of models that knows taking all of the sensor from your hand if you are stressed or not. And this is a mental well-being application. And so you see industrial, you see wearable, edge compute application, high-end. In this case, the request was, we want to count people in a traffic light in India, okay? So a lot of things. You need an NVIDIA GPU for that. So this is where cost doesn't matter. You just need to execute. We're supporting NVIDIA as well. And for example, non-invasive glucose, think about it. This is a revolutionary application from a company called No Labs. How much models you need to train, but still need to be handled application, low cost, low power. And in this case, it was neural network engine. So you see different type of application, exactly the semis I shared before. Unfortunately, I cannot tell who is who, but in the end, each of them won one of that, okay, or multiple. And this is a good example. Other companies, so we mentioned already wearable. Aura Ring, I believe some of you know the Aura Ring, and just today Samsung announced that they want to do the same. So there are 6 sensors in a ring, and Aura is fully committed customer for us, where we worked a lot, training months and months and months on something that is on your ring. Think about, again, low power application, using coprocessor. Some machining is being done really on the edge, some on the gateway, that is the phone, some need to be on the cloud. Again, sleeping awareness is something that you cannot do everything on the edge. But again, this is a good example. Slate safety for firefighters, that when firefighters in California entering to a building, there is a lot of training being done. So if there is a 2-kilometer hit, the training will tell them you need to be aware. So alarm will already turn on saying something will happen. And this is the anomaly detection that we need versus that it's a fire and unfortunately somebody will be died. And again, No Labs, sleeping data type of application. You can read about these companies online, and this is very important. These are the customers that are working with us, paying, that we are supporting them with some specific models, specific technical support, building blocks, using our platform. Now, we are not stopping, because yeah, you have a crazy Israeli working in the company, so we are really going ahead. We are developing platforms, so reference designs. We have these 2 examples here, the non-working one, because we didn't able to ship them from California. We cooperate with Italian company called Reloc and Renesas, building this type of reference design hardware platform for machine learning application running on predictive maintenance motor controls. And we doing this type of human help application or voice with collaboration you see with Nordic and Sentient. So some of the machine learning running on the Cortex, some of them running on Sentient neural network cores. All of that information you can get from our team outside, or from me. My business card is for you if you have any question or support. And what is our business model? So in the end, all of you can today register to the platform. Totally free. You will have unlimited project, 20 minutes per job, 4 gigabytes, 4 hours, 1 seat. It's totally free. You can get it. Normally, when it becomes complex, when you need help, When you need modelizing, customized support, dedicated help, this is where you are becoming a subscription customer for us. There is a fee, a monthly fee with a 12 months contract, and it can go from 3K up to 50K, depending on what you need. But then, this is how you're solving cost of the BOM, because we are here to support you. And this also can answer your question. So just to summarize, you remember I started with that box. What you need to take care is your data. This is where you are. Data in, data forward, upload data, train data, modelize any type of data. And in then you know that someone will do that job and you will see the deployment. It's us, and we are able to support it. Our job is to democratize machine learning to the embedded engineers. This is the message from the founders. And this is how we are doing it. So we will work with more semis. The target is to have all the latest technologies, and we are working with so many new innovation IPs and semiconductors. If you didn't see a semiconductor that's been implemented yet, it will come, okay? We are working with all of them, so then you will have more choices too for your application. That's it. Thank you very much. We have another one question, because we have 2 minutes to go. Another one question? Excellent. So it was clear. Thank you very much, everybody. Enjoy the day.